Hello and welcome to the next episode of the podcast of the FIB, the International Federation for Structural Concrete. I am Nadine, I'm part of the FIB Young Members Group and a research assistant at the University of Natural Resources and Life Sciences in Vienna. I am happy to host this podcast series on concrete sustainabilities. My guests are all personalities from practice and research who are passionate about sustainability in any kind. With them, I want to discuss the diversity as well as the urgency of the topic and find paths into a more climate-friendly future. This time, I have the honor to talk to Mr. Sebastian Spaun, who is the Managing Director of the Association of the Austrian Cement Industry. Welcome.
Hello.
We are currently at your office in Vienna, and I may introduce you as my guest a bit to our listeners first. Since 2015, Sebastian Spaun has been Managing Director of the Association of the Austrian Cement Industry. In German, it is known as the Vereinigung der österreichischen Zementindustrie, in short VÖZ. Before, you have already led the Department on Environment and Technology of the Association of the Austrian Cement Industry. You have a lot of experience there. Other functions you have include, for example, being board member of the Austrian Society for Construction Technology, as well as being a supervisory board member of Austrian Cooperative Research, a network of private research institutes offering applied research and development for companies. You have received a profound knowledge to understand ecological interrelations by studying land and water management and engineering at the University of Natural Resources and Applied Sciences in Vienna. And nowadays, you told me your work's focusing on the decarbonization of cement production, resource-efficient construction, as well as the creation of long-lasting transportation infrastructure. I'm very happy to have you as my guest today, and I want to jump right into the conversation. We have learned from the previous podcasts that the production of cement is insanely energy intense. It emits a significant share of the global carbon dioxide emissions. On a global scale, it is even responsible for somewhat around 5% of anthropogenic carbon dioxide emissions. And you, as the leader and the head of the Association of the Austrian Cement Industry, which efforts does it take into account to lower those related emissions? Can you give some insight on that?
Yeah, thank you, Nadine, for the nice introduction. It is also a pleasure to me to speak to young researchers, young engineers, so the ones who should solve the problems in the future and of today. And we left you a lot of problems, I would say. Let's jump in. I mean, to decarbonize the cement industry, or better said, the whole production process, the whole building and construction sector, we will only succeed if we do it together. And so some years ago, I think 4 years ago, our European Federation came to a concept called the 5C concept. And the 5 Cs are standing for clinker. We need to reduce the footprint, the CO2 footprint of the clinker production, of course. The second C is cement. So all the efforts to bring in the market, to make the research about cements with less clinker content. The third C is the concrete. We do a lot of research about compaction, of working together of the aggregates, of and then the fourth, a little bit wondering, most of the people, is the construction of our society, the construction of our infrastructure, how to construct houses and bridges more resource efficient. And the last C is the C for the carbonation. It was in the last assessment report of the IPCC that the carbonation of concrete was mentioned and fully recognized. And so also there we need research not to lower the quality, but to use the full potential of carbonation.
Thank you very much for this very nice overview and also recap of the 5C approach of the European Cement Association. We also learned from one of the previous podcasts that actually the devil is in the detail, which means that 2/3 of the emitted CO2 emissions are associated to the chemical conversion process actually, and not to the combustion of fuels, which is always important to keep in mind when talking about this issue. Before going more into detail on each of those pillars, I have first another more broad question to you. So we all know that China is the top 1 producer of cement, and China alone is responsible for approximately the half of the emissions associated with cement worldwide. So are the efforts that are taken in Austria just a drop in the ocean that don't have a lot of effect on a global scale, or what would you comment on that?
If you look to the quantitative numbers, you are right, or someone would be right to see it that way. But on the other hand, I'm a little bit proud that my Austrian cement industry, if you compare it to the other states in the world, we are world class when it comes to CO2 efficiency. And there are good reasons why we are world leader. First of all, we have 80% alternative fuels in our production lines. So 80% of our fuel is coming out of the waste cycle. Not recyclable plastic, for example, waste tires and so on. This is one thing. A second thing is that we use a lot of alternative raw materials. So we are around 14% of our raw material is coming out of the construction sector already. So we are using construction and demolition waste. And our kilns are quite modern, using preheater and dry process, of course. And this mixture, having a high substitution rate for fuels, having a quite high amount of alternative raw materials, combined with a low clinker rate, makes us world leader when it comes to CO2 per ton of cement. But to tell you the truth, this is only the first short journey, and the thing we have to solve now is how to go all the way down to zero.
Mm-hmm. And I also wanted to add to the previous statement, China is the top 1 producer, but if you look a bit closer at the data, which means not the production per capita, but the consumption, we see that actually all countries in the world should feel responsible to participate in the process, to find new innovations and to lower the emissions.
Well, if you allow, let me to jump in. I mean, when we look at the numbers of the last 20 years, the cement demand on the world more than doubled. And the reason was China was built from nearly everything, from the channels under the street, the infrastructure and the housing. And if you look to the future, it is very clear for all of us, we can't go on in this line. The next continent, the next country would be India, and then Africa. And we definitely have to change how we develop cities and how we develop infrastructure. So the big thing we have to learn is to do all this with less and less and less material. We simply have not enough material, not enough raw materials, not enough CO2 caps and so on.
The trends still show us that the population will increase and the demand on buildings will not decrease. And I was just today reading an article of Professor Kromoser who said that mass timber construction will also not solve the problem, that also timber has to be handled with care, or we should feel responsible to use as little as possible. no matter which construction material we're talking about. Okay, great. If it's okay for you, we could move to one of the 5 pillars that you were earlier talking about, the actions that the Austrian cement industry is doing to lower related emissions. And I would like to start with the clinker production, the first one. What are actually the biggest challenges to emit less CO2 during the cement production? Are these like financial aspects to implement innovations? Are these missing or slow political decisions? What are the challenges in terms of infrastructure, such as sufficient provision of CO2-free power or hydrogen? What is your experience?
Well, a little bit from everything, I would say. But first of all, the big challenge you already mentioned is our process emission. It's the emission coming out of the limestone when you heat it up. And the only chance to lower this emission technically is our carbon capture. So at the end, after doing a lot of other things we will come to in this talk, we have to lower this process emission. And carbon capture, we step in new technologies which are called breakthrough technologies because they exist in the lab, they exist in other industry a little bit, but no one tried it in a cement plant yet or in a steel plant. So this is, of course, a lot of risk we have to take, or let's say we and the funding has to take. But we are convinced that we have to start now. And you might know that in the northern parts of Europe, we will see the first fully decarbonized cement plants, I would say, in 2 years from now. These are the front runners, and we will then learn if the technology they use can be spread over Europe, for example. But of course, also in Austria, we have projects on this very high range. One to mention would be the so-called project C2PET, where in the first stage, carbon capture is the technology that should be implemented in our biggest cement plant in Mannersdorf. Well, they just went in the European funding in the so-called innovation round as applicate, so we will see in the next month what happened there. So, of course, this is our biggest challenge, how to get rid of these process emissions. And when you look to the emissions from the fuels, I think that cement industry will stay a player in the waste management. So I think also recycling takes up speed now in Europe. Recycling, for example, from plastic, there will always be a rest fraction which can't be recycled mechanically. And so I think we will stay a player in the circular economy. And this means that also the emissions from our fuels coming out of fossil fuels like plastics will have to be captured. We will need carbon also in the future. We have to get rid of the carbon from oil and gas. But when you want to make plastic also in the future, you need carbon or need hydrocarbon. And there probably the carbon from the cement plants, the carbon from the atmosphere, short name direct air capture, will play a new role as new raw materials for the ones that need carbon as a raw material. So carbon capture on the one hand and process efficiency on the other hand are the big topics on clinker production.
We are addressing a lot of interesting aspects in here. I think I would like to continue with the carbonation or concrete being a carbon sink topic. It's frequently mentioned and often also taken up in amongst research studies. Could you tell us how much or how many percent is actually possible to be again captured in the concrete material, and in which stages of the cement or concrete production is it feasible?
The range is quite high that is in the literature. And this mostly depends on which region in the world do you reflect on? The Chinese literature, for example, there was a famous Nature article from Mr. Xi. They mentioned for the whole world that 40% or close to 40% of the processed CO2 we emit from the limestone could be recarbonated. This number of 40% also went in the numbers of the Global Carbon Project or also in the IPCC report. We in Europe conducted a study at a Swedish institute where we came to a number which was around 20% recarbonation to be precise, in the life stage of concrete. And of course, there is a further potential when you recycle then concrete, or the concrete fines especially. So, well, let's see, between 20 and 40% of our process emission, I would say, is the potential. But what we need to fully develop this is much better methods in the recycling stage of concrete. Because as long as the concrete is a bridge or a wall, we pretty good know, all the concrete scientists know how much carbonation takes place there. This is not that much. But when you recycle this and you break it and the surface gets big again, then there is an interesting potential.
Yeah, this would also be a great possibility for recycled concrete to capture CO2 and then again to use it as maybe aggregate.
Well, to tell you the truth, it is only 1 month ago that the first company in Austria got the application for a new cement, a SEM2C cement, where there is already concrete fine in it. So a fraction from concrete fines. And many producers do research to do exactly what you mentioned, to bring these concrete fines coming out the recycling process together with our raw gas. You know, in a cement plant, you have approximately 20% concentration of CO2, 20 to 25, so a very high concentration of CO2. So this would be a carbon capture and utilization with our own product, which is especially interesting. But we also know, and to be also transparent on that with this concrete carbon capture, we can probably solve 7% of our CO2 problem. So it's not enough.
And we can expect this product to be on the market in the next few months, probably, or weeks.
I think it's already on the market, but I think the implementation will be in some weeks.
There's one product I know. It's the Stoiber Green Tech Combi Cement. It's a SEM2C cement, and it's available in Austria since summer 2022. And I was asking myself, are people actually buying this product? Is it more expensive? Is it less flexible? What are the downsides? Do you have any knowledge about that?
You are right. Stoiber, my member plant Stoiber, was the first plant who got the permission of the Austrian Institute of Construction Engineering. So they are in the market, and what the people tell me, they are fine with the feedback from the market. Of course, this cement can't be used for every application. They use the cement for the housing sector, for residential housing, and they are the first interesting projects where front runners in the housing sectors really use that cement now to show that they can build houses and sell houses with a lower footprint compared to the normal cement we used, the SEM2A. The potential for the CO2 reduction is about 25 to 30%, so quite a bit. Well, we are lucky that also other cement plants are introducing this new type.
One comment about it that came into my mind was, why, if it is that easy to actually make a cement with less clinker content? Why hasn't it been done earlier? Was the cement or the clinker too cheap up till now?
The big challenge we face in that is that in Austria we traditionally used all the other main constituents you need to make cement. So we have a long tradition in using slag from the steel processing, the blast furnace slag. We have a long tradition in using fly ashes from the coal power plants. And as you know, we are running out coal power plants, that the end is coming. So one of our big challenges is to have enough materials to substitute the clinker. So, as you know, also the steel industry will decarbonize their processes. Yesterday there was a big announcement from the big Austrian steel producer, voestalpine, that they will change the first blast furnace stoves to electric furnaces. This will lower the amounts of slag, and so we are making research in finding new constituents to substitute clinker. Calcined clay, for example, is this very new product which we have in the research, and this is one of the reasons we only had, let's say, constituents like slag, fly ash for 30%, because our clinker content in the cement is 69%. And to go on, we have to solve two things: to make a cement that fulfills all the functions, and the second thing is to have enough material to do that. We see that we are successful. The cement is good, but now we need to get new main constituents. Calcined clay. Everywhere in Europe we do research on that, and we hope, because this is available, clay is available all over in Europe. But as the word says, calcining means that we need energy to calcine this clay, so it comes not for free.
Which gives some answers about the clinker content and about a bit of the traditional shift to new cement types. Just a few more notes for the listeners who are not so familiar with different cement types. So according to European and here Austrian standardization, with different cement types who differ according to the share of clinker in it and according to, for example, supplementary cementitious materials in it, like mentioned by Mr. Spaun, the fly ash also. And currently new cement types, new so-called climate-friendly or more sustainable cement types are being developed or implemented and also already sold on the market, as we mentioned earlier, for example, the SEM 2C and the SEM number 6. If there are any further details you want to give our listeners on that, please interrupt me. Maybe we can stay with the second pillar that we were talking about the last few minutes, about cement and concrete, a bit longer. And you were mentioning the calcined clay cement. Do you see it as a promising new type of cement? And what in general do you think of clay construction or earth construction? Is it an addition, or can it be combined with concrete construction, or do you rather see it as a competitive aspect?
No, not really. I think it's as I said before, it is very important to find solutions for other countries, not that developed as Europe, not having this tradition in fast building construction. Yeah, I see a lot of potential for clay, for example, in India, in Africa, where, as I said, where we shouldn't copy exactly the technology we use in the advanced societies. And but why not in Austria? So for me, it is interesting. I mean, we are using the clay and calcine it to get hydraulic conditions in these materials. And well, I would say also the Roman constructors used these materials like the fly ash from the volcanoes. And what we do now is not too much different. We are trying to get hydraulic functions in our product, in our mixtures, but where we don't need that strengths, that early strengths, why not using other materials there? I think this is also for the young generation of engineers really an interesting field to use the material which is best suited for your business case or for your application. So I see the future more colored, more materials, more combination of materials, definitely.
Yeah, I totally agree with that statement. I also think that resource sensible and construction material sensible decisions have to be made and not one construction material against the other. And last summer after a conference, I had the chance to travel with a camper van through Norway, and they have like really old churches built out of wood there, and I was really fascinated. And again, coming back to the traditions you said, in Scandinavia, probably timber construction has a much more deeper part in the past and also in the future than in other parts of the world. Great, let's change the topic a bit and come to another pillar of the roadmap to CO2 neutrality of the Austrian cement industry. Let's get to structural concrete design. I would suggest and maybe start with thermal activation of building components. I guess that our listeners who do not know about this possibility would like to get to know more about the principle. How does it work? What is the idea behind? Could you give them some explanations here?
Yeah, we did a lot of research in that field. And we started 15 years ago, actually, because at this time we saw that temperatures already rises, and we saw that the city centers also in Vienna get hotter and hotter. And if we then would react with air conditioning, we would make the situation even worse. So what can the silent power of building mass, which role can it play? There you have to see a second effect. In order to successfully use wind and solar power, storage facilities are needed to bridge the sun and windless times. And concrete in buildings can play an important role in that, because concrete is heavy, so concrete can store a lot of thermal energy, and most important, concrete has a high thermal conductivity. We all know you never would sit on a concrete chair in winter times. And if you activate concrete and you bring in heat or coolness in the concrete via heat pumps, for example, then you really can heat and cool houses with quantitative, I would close to 100% renewable energy, because you store the energy in the concrete parts. So very interesting and also very cheap technology, because the only thing you need are the pipes you have in the floor space heating anyway, and you put the same pipes in more massive constructions like the ceiling, for example. And as you know, if you look to the responsibility of buildings, then you see that buildings are roughly responsible in the world for 40% of the CO2 emissions, but 2/3 of these 40% is the energy used for heating and cooling of buildings, and 1/3 is the building materials. So it is very wise to look at both parts, at the building material, decarbonizing that, and at the same time looking how can I then optimize both the building material and the heating and cooling demand. So this is something I would really appreciate if young engineers think out of the box, combine, don't stay on the material and only on the materials, look what other things materials could solve. It is really important to think innovation, across borders.
Yeah, there's a huge potential, I guess, as I got from your explanation. I think it's important that our listeners understand that in general, renewable energies are fluctuating throughout the day, and that it's actually also a question of how to store energy to achieve a successful transition from fossil to renewable energies. And that way, maybe buildings can be seen as energy hubs. And I also did some previous research, and I want to give an interesting example I came across, which is a climbing gym with a height of just below 20 meters and an area of 400 square meters in Austria in Saalfelden. And it has a massive concrete base with a thickness of 50 centimeters, so half a meter, and it serves as a long-term storage for energy obtained from an integrated solar heating system. And I was really surprised because the article that I came across, there it was written that it did not have any additional costs for heating during the entire winter period. Why isn't this actually the state of the art, and why is it not everywhere integrated already?
Well, I can answer it simply. There are no downsides. There are really no downsides. But the construction sector is very, very slow, or the speed in taking up innovations in the construction sector is too low. We really have to speed up. As I said, we are doing research on this topic, and very practical research since 15 years. And now, after 15 years in the eastern parts of Austria, so in the Vienna, we are taking up market shares. So I would say in the moment we have around 250,000 square meters, which are built with this technology. But in Austria, we are making 4 million every year. So, well, one of the reasons is that for 100 years, the building industry was building the houses, and another industry made heating and cooling. And between the two of them, there was a big wall, and it still is a little bit. So this is what I meant before. We have to have a holistic view on everything, on our anthropogenic materials flows, on our how we build, how we live, where we work, work-life balance, home office, all the things. We have to think that connected, and what is the best solution for whole cities, for new cities, and then bring it down to the ground. It's good to be a marathon runner when you want to bring innovation in the building sector.
So merging disciplines or accelerating is one of the key things, you would say, to reach those goals. I was also very surprised because I came across something called aggregate storage beneath the base plate. In German, it would be something like Schotterspeicher. You could very well take just recycled concrete and realize it as kind of an aggregate storage, maybe also capturing some CO2 there. I would have a few more technical questions maybe on the concept of thermal activation and building component. How long, or is it more long-term or short-term storage possibility? Is it on a daily basis, on an hourly basis? Does it simply depend on the thickness of the slab? And how does it actually work with a consistent surface temperature?
A good question. Very often I heard in the beginning of our research that concrete component activation is a slow system. It reacts slow, and so you are not able to make fast jumps in the temperature. And I always ask back, why do you need a fast reacting system? And if you then go to the details, you see, well, if houses don't have a good insulation and have bad windows, then you need fast reacting system. Before, when the sun goes down, the houses cool down very fast. But we realized in the last years that in the Austrian standard you have to build, that our building envelopes get better and better. You don't need fast reacting systems anymore. The most important thing in the future is to keep a constant temperature the whole year. So let's think about 23 degrees the whole year round. And then the thermal component activation is the best thing to do that, because if the sun comes by the window and sun energy comes in the room, it's reflected by the floor to the ceiling, and the concrete stores this sun energy. But the temperature doesn't react, because if you imagine to warm up a 20 centimeter ceiling by 1 degree Kelvin, a lot of energy is needed for that. So only the ceiling is enough to store energy in a normal social housing in Austria built in the year 2023. You can easily store 4 days of heat. So if there is, for example, wind, and you heat up the ceiling by 1 to 2 degrees Kelvin, and then the wind is gone, mostly we get western winds in Austria, as whole Europe, then the temperature in the room will not fall down more than 1 degree in 4 days. So it's a very simple system, and the storage capacity of a simple ceiling is enough to bridge the sun or windless times. So it's the combination of a good, I wouldn't say terrific, but a good envelope, and the fact that then the ceiling, the normal ceiling is enough. But second questions, should our ceiling be as thick as we are used to it? No, I think it is very interesting to take out concrete where we don't need it. And I'm very proud that 1 week ago in a workshop of the International Energy Agency about thermal component activation, there was a very interesting presentation about a prefabricated ceiling with thermal component activation in it, with all the infrastructure in it. So it is introduced in a very famous building, the so-called Franz Josef Bahnhof, and there 8,000 square meters are built by this new prefabricated ceiling, where on, let's say, 40 centimeters, everything is in. The whole installation, the whole ventilation system, the heating, the cooling, and also the noise reduction. So a very interesting, very revolutionary system. So I think it's going in the right direction. Use less materials for the same effort, and having a lot of functions in one part.
This system you're talking about seems to be very interesting.
It's very interesting, and probably some of the listeners are familiar with Werner Sobeck, very famous architects, and also in your field. And as I read, Werner Sobeck or his office made the calculation, the CO2 calculation on this whole system with very interesting result. So just one example that we are getting multifunctional building part with less material in it.
Yeah, that's what I really like also about your comment, is that this office of Werner Sobeck did for sure the environmental calculation, because that's what I got from my research the last few years, that it's not always obvious which solution is the most sustainable one. So the environmental verification is very important. Yeah, I'm very curious to go through the article or the sources you have, and I guess also the listeners for sure. So actually, I feel like I'm very well informed about thermal activation of building components, so thank you a lot for that. I think other levers in structural concrete design would be mass reduction and also circular construction, one of the topics I discussed with architect Thomas Raum in the previous podcast. I think I will change the topic a bit to research and development in the construction industry. I feel like there's, and what was also mentioned by you earlier, there's an inactivity of the construction industry in terms of innovation research. I was checking some numbers, and according to the European Commission, for example, in 2020, they said that research and development investments in the construction industry accounted of less than 1%. And the automotive industry, for example, which is very strong, had over 30% in comparison. What is your feeling on that? How much updraft or increase does research in the construction industry receive, and how important is especially the newer generation, new blood, and are the companies motivated to implement innovations?
Well, it's always the young generation that should bring in new thoughts and be revolutionary and put pressure on the traditionalists in the sector. But yes, construction industry is a very traditional field, let's say it that way. And of course, many people still are building a house. And the education of the simple workers, well, there is education, but not comparable to let's say it's not only the education, it's also the automation of the whole system. It's still the construction workers you see on the construction sites, a lot of them who build the houses. And so if you want to bring in one new technology, you have to have this in mind. Yeah? Somebody has to use your new building product in mostly in a sophisticated manner, because if you for example, if you bring in concrete that is very sensitive, you have to take this situation on the construction site. You have to have it in mind. So, of course, if you look what timber makes good it's the level of pre-construction. It's the level of automated construction, where a lot of technology can be implemented before you bring it to the construction site. I would like to give you an example. Vienna was one of the cities where the iron concrete, Eisenbeton, it started with iron reinforcement. Around 1900 was invented. It was in Paris and it was in Vienna. And at these times, the engineers were very proud on this new technology. And if you look to the 120-year-old drawings, you will see that there was no slab with a full concrete slab, because concrete was very expensive and so was iron. But what was cheap at this time? Workforce. So there were a lot of people displacing the concrete where you don't need it. And what happened since that? If you look how we build today, we obviously lost all this knowledge. I wouldn't say we lost the knowledge, but workers and workforce got expensive and materials got cheap. And this is, in my eyes, a very simple reason why we build like we build. So we have to go back where the constructors and engineers already were at 1900.
Yeah, we have to revisit the past. I was actually quite surprised because my topic is mass reduction of concrete girders, and I was developing the science of slender concrete trusses. And in a literature study, I found they have already been built like 80, 90, 100 years ago. So it has already been solved. It just has to be re-implemented.
Just to say one word to thermal concrete activation. The first building with thermal concrete activation was a hotel in Zurich 80 years ago. So this technology was forgotten for at least 40 years.
Yeah, this is actually a bit insane to think about. And if we go back even further, I think the Romans also had some kind of similar concept, right?
Well, right. The Romans knew a lot about indirect heating, so heating rooms with radiant heat. They made fire under the floors, and the walls were heated indirectly with the gases, with the off gases of the hot fire. They figured out that it is very, very comfortable to be in a room that is indirectly heated via radiant heat. So they already used thermal component activation and many other things, as we know.
Yeah, I can confirm it's very comfortable. I had an internship in the beginning of my studies at a construction company, and they had a very modern, innovative office with thermal activation of building components, and I really enjoyed working there during the hot summer days. I would like to jump to one of the last topics. I would like to talk a bit still about concrete versus timber. Just today I read an article that said currently timber is could be also compared to the superfood of a built environment salad. And I was also reading some articles about natural carbon cycles lately. I found an article that said a tropical forest after logging continued to be a source of carbon dioxide and did not serve as a carbon sink at least for the first 10 years, which was quite riveting. And I also found that a considerable amount is stored in the leaves and in the roots and not even in the log itself. I feel like the understanding of the natural carbon cycle is not trivial or simple at all. And that there's also a temporal or a time component that we have to consider. So we should keep the CO2 emissions low now and better now and not tomorrow. What could you comment on this, the whole complex natural carbon cycle? If I would be a listener, I would be really confused right now.
Well, to be honest, as I'm leading a research institute on concrete and being the managing director of a cement association, maybe you will not trust in my words, but I will try it. I will be careful. First argument, we need all building materials. I read very often in newspapers that wood can substitute concrete on a quantitative level. It doesn't take you too long to realize that this can't be the truth. I mean, we are using in Europe, I would say, 5% at the maximum are wooden building materials, and the rest are, concrete bricks and so on. And if we would try to double this 5%, let's say it that way, this would mean, simplified, that we would need double amount of forests. So there is a potential, and I think the potential to use these materials together and also have a competition between the ideas is good and is what we need. But to say that wood has the chance or to substitute concrete quantitative is not the reality. We are using in the world around 15 billion cubic meters, and the global sawn wood is around 0.5. So you see, it doesn't fit together. This is one thing. The second thing, your question coming to carbon cycles. If you look at the global carbon cycle, you will see that there are two arrows going up from the Earth to the atmospheres. The biggest is the emission from fossil fuels. It's 37 billions, gigatons, 37 gigatons. And then you see a second arrow. It's called land use change, mainly deforestations. It's about 5 to 6 gigatons per year. And this deforestation doesn't only take place in Brazil. It's in the meantime taking place nearly everywhere in the world. And on the other side, there are two arrows going down. These are the sinks of the world. So two going up, fossil fuel and land use change, and two going down. And mankind is happy to have the two. One is the ocean which is still able to absorb a lot of CO2, but some of you already heard that the plankton, which has a little lime shale on the backside, that it already starts to be solved because the CO2 is acid, and acid on lime, you know what happens. So probably the oceans are coming to the capacity is coming to an end. And the second arrow going down are the forests of the world, the growing forests of the world. And if you then make a balance between 40 gigatons going up and only 20 are taken out by these two things, you see that the difference is 20. And 20 is the gigatons are going in the atmosphere. And what we see today is that we have already 420 ppm CO2 in our atmosphere. And whatever you do in future, you have to avoid that further CO2 is going in the atmosphere. And this means for me, we have to dramatically bring down our emissions and the emissions from fossils. But what most people don't know, you also have to bring down the biogenic emissions. There is no CO2 neutral emission in the world. If CO2 comes out the chimney, it's CO2 that will stay in the atmosphere for another 1,000 years. So some stories are too simple that we should start to ask if it's right as it is told. We need all building materials. Competition is needed to make both sides or all the building materials better. But I think we should more concentrate on decarbonizing and dematerializing the building materials or the kind we are constructing the housing and the civil engineering, and not focus too much on this substitution story. In my eyes, it's a wrong focus. The levers in substitutions are low compared to really reconstruct the world and decarbonize it.
Yeah, great. Thank you for this tangible explanation. We have a very general rule for our listeners. Be alert and pay utmost attention whenever any answer to a question is too simple, which generally applies to everything in life, I would say. So I have one final question for you. What is your personal opinion? Can the goals of the Austrian cement industry be achieved? The 5 pillars, the roadmap to CO2 neutrality. What is your personal opinion?
Well, I'm convinced. It took us 2 years with our industry to develop these roadmaps. And the first goal we have in this roadmap is that 2040, we want to be finished with the decarbonizing, also with having this climate-friendly, more climate-friendly, not climate neutral at the time, more climate-friendly cements. So 2040, we would like to bring down the clinker content in our cements to 50% as a medium value above. So this is in 16 years, and to have it then fully brought down and fully implemented in the value chain, the market accepts it, the builder is a big effort. And of course, as I said, the first companies in Austria are in very concrete projects to implement carbon capture. And this means in the beginning to bring this carbon per train to the sea, to the North Sea or the Mediterranean Sea. We will need pipelines in the future to make the transport much easier. We will need hydrogen to be able to reuse the CO2, to make products out of it. And we will need, as a society, a lot of renewable energy, a lot of the renewable electricity. But we have the technology. I would say we have the money to do that in Europe. The only thing we have to solve is not being replaced from industry out of Europe that this is the biggest threat and the biggest challenge for our industry. Decarbonizing means that everything gets more expensive. Decarbonizing means that steel and concrete, steel and cement will at least double in the production costs, probably more than double in the production costs. And this is not a problem for the society, because if you double the production costs of the cement, a building would cost 0.4% more, which is not the problem for the society. Or a car would cost, I don't know, 500 euros more, not more than that, to be decarbonized. But the problem is the so-called carbon leakage, that other areas in the world then replace us in Europe. There's a lot to do for us and for the politics, and most important for the young engineers to show us better and even more efficient ways we are working on now.
Yeah, thank you. I really like how you are painting a positive, multicolored future, but also say the truth that it will be exhausting to reach all those goals. And for all the young engineers listening, you can see that if you want to, or you are motivated now, you can be a part of decarbonizing the cement industry. And young blood or new blood in research and in practice is always welcome.
You are right.
I think now I want to come to an end of the podcast, and thank you very much for your time, Mr. Spaun, for being on this podcast and allowing us some insight into the efforts of the Austrian cement industry to achieve CO2 neutrality by 2050. For our listeners, I will link the information about my guest, Sebastian Spaun, and the Association of the Austrian Cement Industry, as well as addressed contents at the website, as usually. And thank you very much for listening, and until next time. Thank you very much.
Thank you.